Hello everybody and welcome to video 3 in this Rust programming tutorial series. In this video, I'm going to be showing you variables. Now I know that sounds basic, I know many of you know variables, but they work a lot differently in Rust than in other languages, so make sure you stay tuned and pay attention to all of the details because there is quite a few, and it's pretty fundamental to understand this before moving forward. Now, if you guys are enjoying the series, please do leave a like, leave a comment, let me know what you'd like to see in the future of this series. I myself am no Rust expert, I've just been learning the language for a few days, and obviously I feel qualified enough to teach you kind of the basic stuff and go through some of the cool features. So with that said, we can dive in here. I will mention though I do have a programming course, programmingexpert.io. If you guys haven't yet, just check it out from the link in the description. Even if you don't want to purchase it, I'd love to hear your feedback on the course, what you think of the curriculum. So far, we've had great feedback from people that have actually purchased it. And well, if you want to become a software engineer, learn advanced programming and all of that stuff, check it out from the link in the description and use discount code TIM. Okay, so let's get into this here. What I want to start with is variables. So how do we make a variable? Well, to make a variable, there's a few ways, but the first way is to do something like let x equals, and then we can go with something basic like 4. So there we go. We've just defined a variable. The name is x, and it is storing 4. Now, the first thing we need to understand here is that Rust is a statically and strongly typed programming language. What that means is that when you define a variable, it's going to be given a type. Now you can explicitly define that type, meaning you actually write out what the type is manually, or you can let the compiler implicitly decide the type. So here, this is what's known as an implicit type assignment or type decision, because we're not manually specifying what the type of x is, but at compile time, so when the compiler starts running, it's going to see that x is storing an integer, and it's going to implicitly assign the type of x to be a type int. I'm going to get into data types in the next video, so stay tuned for that, but just keep that in mind. You have explicit and implicit, and by default, when you're doing this, it's implicitly assigning the type, and what that means is you cannot change the type of this variable throughout the program. So in Python, for example, you could do something like let x equals 4. You wouldn't have the let keyword, but you'd have x equals 4, and then down here, you could just go x equals, and then make it a string. Here, that does not work, and the reason that doesn't work is because you can't assign a string to type int. Okay, now one quick thing here, if you want to explicitly define the type, you would put a colon here and you would write the type. So if I did something like u32, then I would be assigning this to a uint or unsigned integer 32 type. Again, we're going to talk about that in the next video. Just want to quickly show that for anyone wondering. Okay, so we have let x equals 4. Let's just start by printing this out. So we'll go print line, exclamation point with our semicolon, and then we're going to put what's known as a formatting string. So I'm going to write something like x is colon, and then I'm going to put my curly braces here, and then I'm going to put a comma, and I'm going to put x, and what this will do is embed the value of x inside of my curly braces in the outputted string. So to show you this, let's just go to our terminal. Notice I'm inside of tutorial 3 here. I just created that before the video. And now I can do something like cargo run, and you will see that we get, oh, wait, why are we getting hello world? I think I'm in the wrong main file. Sorry about that, guys. Let's go to tutorial 3, source main. Let's paste that in and let's rerun. If you have no idea what I did, don't worry, but now we have x is 4. Okay, so that's working, and that's how you embed a variable in a string. However, let's try doing something that, seems obvious that we'd be able to do, but that we actually can't do. If I go here and I type something like x equals 5, obviously you're going to assume if you've come from another programming language that, okay, yeah, x is going to be changed to the value 5. Now it's going to print out 5. But watch what happens here when I go to my compiler and I run this. Notice that I actually get an error here. It says cannot assign twice to a mutable variable x. That's my main error. It gives me kind of a snapshot of the program, and it actually tells me exactly what I need to do to fix this error, as well as where the error occurred. So I'm actually very impressed with the error handling and messages from the Rust compiler. I haven't seen anything quite this good in many other languages, so just something to note there. Anyways, the reason we're getting this error is because by default in Rust, all variables that we define are immutable. Now, immutable just means we cannot change them. And so when I do something like let x equals 4, by default, I cannot change x. I just can't reassign a value to it without redeclaring the variable. So the way we would fix this is by putting this keyword mut here. Now, mut or MUT stands for mutable. So by default, it's immutable, but we can explicitly define this is going to be a mutable variable, and now this will work. So I said let mutable x equals 4, and now I'm allowed to change the value of x throughout the program because I've made it mutable. Okay, so let's go here. Let's run this, and we should see that we don't get any errors, and we get x is 4 and x is 5. Great. Now, one thing to note here is you may get some warnings in your program. So for example, if I do this, like let mutable x equals 4 and then x equals 5, and then I run the code, it will compile, but we will get some warnings. So you can see x is 5, and we're getting a warning. It says value assigned to x is never read. Now, the reason we're getting this is because we've defined a variable x here. We've then changed the value, and we didn't really need to do this. This is kind of illogical code, right? Really, what I would do is change it to be like this. So we just directly assign to x, because why am I writing x equals 5 down here? It's kind of hard for me to really articulate it more than that, but that's why we're getting a warning, because we kind of have code that's not really necessary. Now, when we run this code, let's clear and run it again, we're going to get another warning, and it says variable does not need to be mutable. That's because we're not changing x, so we don't need this mutable keyword. So if I remove this now and rerun, of course, we are going to get it compiling with no warnings. Okay, so that was the basics there on variables. Now, let's see how we actually change the value of x without making it mutable. So what I can do is something like let x equals 5. Now, at first glance, you're going to think probably, if you're coming from another language, that I'm going to get an error here. And the reason you would think that is because I'm redefining a variable that already exists in this scope just being the function that I'm writing in. However, this is actually not a problem in Rust, and when I go and compile the code here, you're going to see that this is completely fine. I get x is 4 and x is 5. Now, the reason for this is I am actually allowed to kind of recreate x here. What I'm actually doing here is creating a brand new variable that has the same name as x, and I'm just assigning it now to the value 5. So I'm kind of overriding, in a sense, this previous variable and just giving it the same name, which in this case, it's 5. So now, if I go here and I run this, you're going to see x is 4, x is 5, no problem whatsoever. And that's one of the ways you can get around that kind of mutability issue, right? Because if I had x equals 5, then I would need to make this mutable. But if I don't want to make the variable mutable, then instead what I can do is just redeclare it using the let keyword. And similarly, I can do something like let x equals x plus 1. And now I'm going to increment the previous value of x and assign that to a new variable called x, and there's no problem doing this. So let's go here and rerun, and notice that x is 4, x is 5, no problem whatsoever. Okay, so that was the first thing to show you. The next thing to show you with this kind of way of declaring variables is what happens when you have kind of name shadowing from different scopes. Now, if you're unfamiliar with name shadowing, essentially this means you use the same variable name, but from a different scope. Now, a scope we can kind of think of as these indentation levels here in the curly braces. We'll get more into them later when we talk about functions and all of that, but let's have a look at this example. So what I could do is just make my own scope. Now, I'm just making a scope by putting a set of, curly braces here. You don't have to worry about exactly why this works, but let's watch what happens when I do something like let x equals 2. And then I say FMT, I'm thinking of Go here, print ln exclamation point, and then I put x is colon. I really could have just copied this, I guess, and then x. So just take a guess, pause the video if you want, and tell me what you think the output of this program is going to be. Okay, so I'm gonna run the code now. Let's go here, let's run this, and notice that I get x is 4, x is 2, and x is 5. Now you can kind of have a look at them side by side here. I'll put it to the right. It's a little bit weird why we're getting this, right? You might have imagined that what was gonna happen is we'd get x is 4, x is 2, and then x is 3. And the reason you'd probably guess that is because we're saying let x equals 2. Well, when we do that, you'd think x is going to change, right? We're redefining x. Now, the reason that doesn't happen is because we're saying let x equals 2 inside of a different scope. So let me go back to the code here. So this and this are in the same scope. This is kind of an interior scope to this main function. So what that means when I say let x equals 2, x is only equal to 2 inside of these curly braces right here. As soon as we come outside, x is no longer equal to 2. That's just not. It's only equal to 2 here. When we come outside, x is equal to 4 because inside of that scope, that's what we define x to be equal to. I know, seems kind of weird, but that's really how it works. When I define it in this scope, it's not being changed in the parent scope, it's only being changed in this current scope. So when I come down here, we're reusing the previous value of x, not the one that was defined in the interior scope. Now though, let's get even more complicated, and let's do something like x, and actually let's just go -2. So now, again, take a guess at what you think the result's going to be. I'm about to run the code. Let's go CLS and cargo run, and notice I get x is 4, x is 2, and x is 5. Now, the point of this example is that I can use the x from the exterior scope in the interior scope, right? So this is exterior, this is interior. I'm able to access this x from inside of here and use it totally fine. That's all right. But again, it doesn't change the x outside because I'm defining it inside of this scope. We'll see a lot more of examples of this later on, but that is what I wanted to show you here in terms of kind of the name shadowing and the, I don't want to call it strange behavior, but the behavior that occurs when you do this. Okay, so that is the basics on variables here. One more thing to have a look at is that when you're using this let and you're redefining variables, you can change their type. So when I do something like let x equals hello here, if I close my, what do you call this, my double quotation mark, this will actually work fine. So if I go back here and I clear and cargo run, notice we don't get any problems and we're printing out hello. Now that sounds contradictory to what I showed you before, but the reason this works is because I'm redefining x. So x is now a new variable. It's going to get a new type. The new type here is going to be hello, and this works completely fine. So, or sorry, the new type is going to be string, not hello, but it is string because we put hello here. So this was an int, this is a string. However, if I tried to do this, right, where I have mutable, and then I run the code, now you're going to see that we get an error. It says expected integer, but found the type of string. Hopefully this is kind of coming full circle, but since I'm not making a new variable, I'm trying to mutate an existing one, I can't change the type. But if I just go let x, creating a new variable, I can change the type, and that's completely fine. Okay, that's almost everything I have to cover. Last thing I'm going to cover is constants. So a constant value might seem very similar to a, what is it, an immutable variable. It is actually similar, but the construct and kind of the, sorry, not the construct, the convention on how you write it is different, and there's a few rules that you need to follow. So when you use this const keyword, you're actually creating something called a constant, right? You're not creating a variable. A constant is something whose value and type cannot change throughout the entirety of the program once it's defined. So let's just have a look at some examples here. The convention when you write a constant is to write the name in all uppercases separated with underscores. So I could do something like seconds in and then minute, and this is how you're actually supposed to write it. So all capitals, you do, again, using underscores instead of kind of camel case, and this is actually referred to as, I think it's capital snake case or something like that. Now, when you define a constant, you also have to specify the type of this constant. So I have to do something like, say, U32, standing for unsigned integer 32, and then make this equal to a value. I need to define a value for it. I can't leave it kind of blank, right? So here I'll just go with 60 and put my semicolon. Now, though, we can print this out. So let's say println, exclamation point, and let's just do kind of an empty formatting string here, and then do seconds in minute. Okay, so let's run this. Cargo run, and notice that we get 60, no errors, everything is working fine. However, if we were to remove this type, we would get an error. And if we tried to change this, right, seconds and minutes is equal to 100, and I go here, we'll get an error. It says cannot assign to this expression because this is a constant. Now, same thing if I do something like const, let's just redefine this and change the value here, and let's see what we get now. Okay, so let's go. Let's clear, cargo run, and notice I get a problem. Oh, it's saying it didn't find a semicolon, so let's just fix that first before we look at the other error. Okay, clear and run, and again, I still get this problem. It says seconds a minute is defined multiple times, so unlike a variable, you cannot reassign or kind of redefine this constant. Once you create it once, it's there. You cannot change it. You cannot redefine it. Okay, so I think with that said, I am going to end the video here. I know I didn't show you that much, but there was a lot of details related to the variables and to the constants, and I wanted to spend some time on this to make sure it was super clear, because there is a lot to kind of unpack here with a strongly and statically typed language, especially if you're unfamiliar with that. In the next video, we'll talk about data types. We'll start to clear some of this up. Then we'll get into console input and if statements and all of the other kind of cool features that Rust has that other languages don't. If you guys enjoyed, make sure to leave a like, subscribe to the channel, check out programmingexpert.io, and I will see you in another one.